Okay, in the last video we did an example that had x's and y's, and I just want to talk a little bit about polynomials very briefly in two variables. And let's say x and y for this example. So I said basically you could treat y like a number. You could even treat x like a number, just we don't know what these numbers are, and we can do everything the same way. And what I said in the last video is actually absolutely true. There's actually nothing to worry about there. As a matter of fact, we could think of some of those formulas that we had of allowing a to be x and b to be y, and then we've been dealing with formulas in two variables for a while. However, let's just formally define what a polynomial in two variables might be, and that's going to be anything of the form a x to the k, y to the l, where k and l are non-negative integers. That means that they could be 0, 1, 2, 3, and anything going onward. And a is any real number except for 0. So it could be pi if we really wanted it to. It usually won't be. It might be something like 5 or negative a half or negative 37 over 2 or something like that. That's all fine. So this is a monomial in two variables. And if we take a sum of monomials in two variables, we are going to have a polynomial in two variables. You might object for a second. You might say, hey, wait a second. If k is 0, or if l is 0, or if they're both 0, how is this a polynomial? How is this a monomial in two variables? Well, we want to talk about things of the form, say 3xy plus 2x minus y plus 7. And you'll notice that some of these terms don't have x and y. This has an x and no y. This has a y and no x. Well, you could think of this as a monomial where the coefficient of x is 0. And this is a monomial where the coefficient of y is 0. And this is a monomial where both coefficients are 0. And that's just fine. In that case, all of these things are living in the same space. We can add them, we can subtract them, we can multiply them. In a way, we've been doing that exact thing when we deal with sort of equations of the form a plus b squared. Well, we could just have been thinking about that in terms of polynomials of two variables, right? What is this? X squared plus 2xy plus y squared. So when I said before that we could just treat y like a number, and we could even treat x like a number, we just don't know what that number is, well, that's a fine way to deal with it. However, for the definition of what a polynomial in two variables is, it's a sum of these things. Now, you'll remember that we had something which we called degree that we've been talking about a lot, degree 2, degree 3. Which of these are we going to let be the degree if we have two different variables? Should the degree be k or should the degree be L? Well, what we're going to do is we're going to allow the degree to be the sum. And that sort of matches, because think about that. You have two x's here, you have two y's here, and you have an x and a y here. The degree, it makes sense for it to be the total number of variables sort of appearing. And what do I mean by appear? I mean they're all multiplied together. So it doesn't matter if we say, if we have this would be degree 3 plus 1, which is equal 4, or this is also degree 2 plus 2, which is equal to 4. This first one is x times x times x times y. There's 4 variables total. And this next one is going to be x times y times y, 4 variables total. So we can think of it as the total number of variables appearing. That makes a lot of sense in order for us to use that as our definition of degree. Because if we say have 4 total variables appearing and 4 total variables appearing, and we multiply these together, what do we get? Well, we have 8 total variables appearing, and that fits very nicely with 4 plus 4. So just a couple of words in that. We're going to stick to one variable for most of what we do, or we're going to stick to polynomials in one variable where maybe there's something scary, a y or an a or something like that, but we're very concrete about the fact that, hey, a is some number that we don't know about, so let's try not to think about it as a variable. But okay, that's most of what I wanted to say now about polynomials.